So this is going to be the Unit 4 Trigonometry Test Review. Here, I'll even put it on there. Unit 4.
Do we have to turn this in?
Nope. What?
Is this our review for our test?
Yes.
Now, we're going to go through this, and one of you two's got to move. I'm not going to talk over you two. One of you two's got to move. Yes, you two. One of you two, break it up. All right, right here, missing side of each triangle using any method. Check your answer using a different method. We're not going to have to go through and actually check the answer on this. Okay, there was a way that I showed you guys to solve it, which is always going to work. Always going to work. So now, A, this mark right here means it goes with F, right? Say yes.
Yes.
Okay, so now that means that these two triangles are going to go together, that they're supposed to be similar. How do I set up to solve for the missing sides? Okay, in a right triangle, how would I find the missing side of a right triangle? Excellent. A squared plus b squared equals c squared. So that's my Pythagorean theorem. That is my Pythagorean theorem. So with my Pythagorean theorem, this is my A, this is my B, and this is the C, right? Or either way. So it's A, B, C. Okay, but your C always has to be your hypotenuse, and that's the one I'm looking for here. So I'm going to go through and set this up now. So it should be 5 squared plus 12 squared equals whatever my AC is. I'm going to use that as my C squared. And I get 25 plus 144 equals C squared. 169 is equal to C squared. And then to undo the square, I square root. So C square root of 169. So I know you guys should be practicing this on the calculator. So it gets really frustrating when we get time to a test and they're, hey, I don't know how to put this in. And it sounds just like that too. All right, so square root on my calculator. So, right, control X squared, 169, hit enter. So my C value is 13. Yeah, square root.
Wait, square root of the square root, what's inside the number? Is it 14? I can't see it. Okay, sorry.
169.
Oh,
Yeah.
so because the 5 and the 12 already have the exponents and we did all of that, that means you don't have to put the exponent on the 169.
Yeah, because if you guys remember, please excuse my dear Aunt Sally, right? Do you remember what that stands for? Parentheses, exponent. So we did the exponent before the addition, right? So exponent before multiplication and division, then addition and subtraction comes last. So we did the exponents over here, then we did addition, okay? And then we worked on it, okay? This value is 13. Yes? Okay, so now we're going to use similar triangles to find the other side. So I could use Pythagorean theorem to find this one over here if I wanted to or needed to. But let's go ahead and start off with sides that I know. What are corresponding sides that I know? If these two are similar, what two sides go together? I heard it, 5 and 10. 5 and 10, right? 5 and 10, so this 5 goes with this 10, right? So the 5 and 10 go together, and that would be equal to, now I'm trying to find the other side, right? The other side DE is still missing, right? Yes. Hey, do me a favor. don't want to say your name during the video, so.
What's wrong, mister?
I won't catch it. I'll let it drop right on the floor.
Wait, no, don't
Okay.
do that.
You seem troubled today.
No, this is like test review. Should be, a lot of days, most people don't pay attention. Okay? They sit around playing on their phone, don't really pay attention. This is the test review. I'm telling you, I'm reteaching exactly what is on the test. So, majority of your grade is this test. I'm trying to make it be like, oh, hey, that's easy. Oh, yeah, I didn't get it before because I wasn't doing anything. Because I was looking at my Instagram or, other people's Snapchat and not paying attention. So I'm not trying to be mean. I'm just trying to be, right, this is the last moment right here. So how would I set up to find this missing piece down here?
Multiply by 2.
Huh?
Multiply by 2.
No, not yet, because I have to have a fraction. I know what you're saying. Yeah, go ahead.
What's called x over 12?
Would it be x over 12? So let's look. If it's 5 over 10, it should be 12 over x. There we go. So this would be 12 over x, right? And so yes, you can see that there's a scale factor of 2 here, right? Okay, you did see that scale factor 2. Yes, you could do that. So let's go ahead and do my cross products here. So 5 times x gives me 5x equals 10 times 20, 10 times 12, 120 divided by 5. X is 24. So the way he was saying is that he looked and compared sides. That goes 5 to 10, that means this one's twice as much. Okay? This one's 13, that's 26. It's twice as much. This one's 12, and this one's 24, twice as much. By looking at it and comparing it, you could try and figure out scale factors like that. Okay, yes. No. The other guy's gone. Huh? No, he's over there. Alright. A step has a height of 5 inches. A ramp starts 4 feet away from the base of the step. Make an angle of 5.9 degrees with the ground. What can you say about the angle the ramp would make with the ground if the ramp starts further away from the step? Okay. Now, let's start off with here. I'm going to sketch this. We said this is 5 inches, right?
Mm-hmm.
And this one right here is going to be 5.9 degrees. That's 5 inches right there. Okay. So 5 inches are there. Alright, that guy came back. Now, what do you think would happen? What do you think would happen? Angle would, what can you say about the angle the ramp would make with the ground if the ramp starts further away? So, let's do it again. I have the 5 inches there. What do you think the angle is going to do?
Get wider.
Get what?
Wider.
Wider? Okay, so let's say if we're starting at 5.9, should it be more or less or the same?
The same.
It should be more?
Yeah, no, it should be more, isn't it? Because the thing's getting bigger.
Okay, so now let's look at right here. So I'm going to give you guys another example. So this is 5.9. Let's make that one 10.
Mr. Patrick.
Yes.
Is the side remaining at 5 inches?
Yeah, this side is staying 5 inches, but this side down here is longer. Okay, so you guys think about it as you keep going. So let's look at ones that we know. We know 30, 60, 90, right? So this is going to be 5, we're at 3, and 10. Okay, so it's going to be this. And then if I look at another one, it's going to be 5, and this is going to be 5. This is my 45, 45, and this one's going to be 5 rad 2. So as I look right here, as going from 45 to 30, is this side down here on the bottom getting longer or shorter? It's longer. So if I'm decreasing the angle, so if I'm going from 45 to 30, this side goes from 5 to 5 times rad 3, which is actually a lot more. So this is actually going up more. So as I decrease the angle right here, what's happening to the side?
Getting bigger.
Gets bigger. So from right here, here's my 5, and this is extending it out. So whatever this is, so this is going to make the angle smaller. So if this angle over here gets bigger, it shrinks it. So this right here, the angle would decrease, and the side, as the side gets longer, angle would remain the same, angle would increase. If it increases, that means that it would actually get smaller.
Oh, okay.
Cannot determine. Nope.
They have a rash.
Yes.
So if the side stays the same and it gets longer, then the angle decreases, and if it like shortens, it increases.
Okay. I'm gonna yes.
So if it get bigger and it's decreasing, it's decreasing.
I'm gonna show you guys. I have pencils because we know the size of these pencils. Okay. We know the size of these pencils here. Okay. Yes. Okay. So we know the size. So what I'm going to do is, okay, I'm going to keep one of these right, okay, like this. Now, so let's pretend like this is my triangle. This piece, this is my ramp, okay? This is my ramp right here. So now I'm going to keep making this, okay? I'm going to keep making this the same right here. So I'm going to extend this one further out. So as I keep extending this out, okay, let's look. So as this gets longer, I have to add more pencil. There we go, pencil. So I have right here, so I'm going to keep extending this out longer and longer and longer. I'm going to have to increase this right here. So as this gets longer, my angle starts going down. The angle starts going down. As this gets longer, the angle goes down. Little sense or no? Completely lost. So, bigger the angle, okay, they're all three the same size, so that's going to make this a 60 isosceles, so this is 60, 60, 60 right here. So now I'm going to adjust two of the sides. So now right here, what did I do to this angle right here?
It decreased.
I got it smaller, right? So the side opposite, what happened to the side opposite over here? The side gets smaller when the angle gets smaller. So the side opposite over here will always get smaller if the angle gets smaller. Yes? So think of it extending and adding another pencil. That's what I was trying to get to. Go ahead, yes.
It was called, but the problem that we just did, the side didn't get smaller, it stayed the same.
This side right here. This side was stayed 5 inches.
Yeah.
This side stayed 5 inches. If you notice, this is my piece that actually stayed, right?
Yeah.
This piece stayed, and then, so the rest, so as I extend this, so if I shrink this, okay, so now in this case right here, let's see if I could actually make this to match my ramp. Okay. So now, my ramp is going to try to stay the same. Okay, so I'm going to make the angle bigger. So I'm going to open it wider, right? Alligator mouth, open it wider, right? So I am going, it's not sliding very well. as the angle gets bigger, the piece over here also gets bigger, doesn't it?
Yeah.
Because it connects over here. So as the angle opposite gets bigger, okay, the side gets bigger. So I'm going to shrink it now. So as I shrink the angle, the opposite side gets smaller. Now, I'm going to apply this one again, but I'm going to rewrite it for this one right here. So you said, let's say the ramp.
Mr. Butcher,
Yes.
I'm still like really confused. You said that one side stays the same.
Yes.
But,
The 5 stays the same. So I'm going to redraw it again.
okay.
I'm gonna redraw it. So let's see if I could actually get this closer to right. So I'm gonna show you guys now. This time I'm gonna look at it from a different angle. Okay, we're still talking about this one over here though. Okay, all 3 angles have to add up to what?
180.
180. All 3 add up to 180, right? So I need to figure out that one. So let's go. Let's figure it out. Remember, these 2 together have to add up to 90, right?
That's 5.9. Right?
Yes, and that this means this one over here is 84.1. Yes. 90 minus 5.9, right?
Yeah.
Okay, so the side opposite here, this is the side that we're making longer, right? This side is what we're going to make longer. So if I make this one longer, what do you think is going to happen to the angle?
It's longer.
Think about it. Bigger the angle, bigger the side, right? If the angle gets bigger, the side gets bigger, right? Okay, so look at the part that's actually from here to here, right? So I'm gonna make the angle bigger, and so now it's going from here. So if I make the angle bigger, does the side get bigger too?
Yes.
So I'm covering more side. So now if I'm gonna shrink the angle, right here, smaller angle, smaller opposite, right? Is anyone still awake? Yeah, I heard one. Okay, good. All right, so again, I'm looking at it like this. So they said that they're going to make the red one right here longer, right? So if they make the red one longer, I'm going to redraw it now. So this one is still my 5, and this is still the 5, right? There's this. Now, I don't know what these angles are, but this one is longer. This one right here is longer now, right? So what's going to happen to this angle? So if I make this side longer, this angle over here in red gets bigger, right?
Yes.
Gets bigger. The angle over here gets bigger.
Yes.
I'm almost there. I'm almost there. Let's say for instance, just for the sake of math, this gets longer and this one right here becomes, so since that gets longer, the angle gets bigger, so let's say this angle is now 86 degrees. Do you guys agree with that? If the side gets longer, the angle gets bigger, right?
Yes.
Are we okay?
Yes. Yes.
Now, these 2 angles have to add up to
90.
90. These 2 together add up to 90, right? So let's do it again. So 90 minus 86 gives me 4. 4 degrees. So now, what happened? Ah, crap. 4 degrees. What happened to this angle from here to here? It got smaller, didn't it?
Yes.
That's what's happening. So if this side over here gets bigger, yes.
Okay, I was just confused because one side got bigger and then the angle got bigger as well. But
The only one that's not changing is this.
yeah, but what's it called? The hypotenuse segment was
gets longer also.
Yeah.
This gets longer also, but if I'm doing it, it's this right here. So this gets longer and this gets longer. Does that make sense? But as I pull it away this way, this has to get longer for it to keep staying at that. Okay? Does that make sense that this is now 4 degrees? So if this side on the bottom, the adjacent, gets longer, that means my angle decreases. That angle decreases. Why do you think I'm putting in such an explanation for this problem right here?
So we understand for the test?
Because on the test, you're going to have something really close to this, and you're going to have to think about it and apply this. Not in the same way, but something similar. All right. Yes. With that problem? Yeah. It's right here. All right. It says right here, number 3, Americans with Disabilities Act states that ramp must have an angle of less than or equal to 4.8 degrees. 4.8 degree angle in a right triangle and 1 to 12 ratio for the legs. Select all ramps that meet with the American with Disabilities Act. So 1 to 12. Okay? A ratio of 1 to 12. So it should be the rise, overrun. So what is my ratio here? Is that 1 to 12?
Yes.
So A works out, right?
Was it 12 over 1?
No, it's 1 to 12. Now, let's look at B. Does B work out? What is the rise?
40.
Over? Okay, does that reduce to 0.3? What is 0.3? Is well, it should be 1.3, right? 1.3? Yes. As a fraction, that comes out to be 4 over 3 as it reduces. Now, is that more? Is that more? Hey, shh.
Yeah.
That is more. More or less, right? So this is more. This is wrong, right? What about this one? 10 to 120. 10 to 120. So rise over run. So 10 over, that comes out to be 1 over 12, right? Huh? So this one's okay. What about D?
No.
That is 1 over 15. Now, is that more or less than? Because the act says it cannot be more than.
It's less.
Okay, less than or equal to. So this is less than, right? So you can put this in the calculator and your decimal is less than whatever you get here. So this one's also a yes. What about this one? 2 to 15. Is that a yes or a no?
No.
Let's see. You know what? I'm going to do the math on this now. So 1 over 12, control divide. So it's supposed to be, rise over run is going to be 0.083, basically. 3 repeating. So this is 1.3 repeating. Is this more? Say yes.
Yes.
So that why is this one's no? Is this one right here that? Say yes.
Yes.
Yes. So this one is a yes. This comes out to be 0.083 repeating. 1 over 15, is that going to be less? 1 divided by 15, control divide, 0.06 repeating. Is that less than this?
Yes.
It is less than, so that one is a yes. 2 over 15. I get 1.3 repeating. Oh, 0.13, I'm sorry. Sorry, you're right. 0.13 repeating. So, is that more or less?
Less.
We're comparing it to this, right?
Yeah.
Think of this in money. So 0.083. That's basically 0.08
Oh.
it's more.
cents, right? That's 8 cents right there. Isn't this going to be 13 cents?
Oh, yeah.
So money-wise, this one right here is more than that one, right?
Yes.
So that one's a no. All right, now
Look somewhere here.
what you talking about, Willis?
Look somewhere here.
Okay, so actually I gotta try and get through a lot of this. We have like 8 of these or something like that.
Is this a grade?
Should I make it a grade to make you do it?
Hell no.
Would you do it anyway?
Yeah.
Probably not. Kind of like that trig worksheet that still ain't done. Okay,
Who's like who?
if this is a 45 here, that's a 90. What's this one?
45.
This is the hypotenuse, isn't it? So, tell me what the sides are.
I was inviting her.
Right,
I was inviting her.
It's 8.
I thought it'd be like
2. 8.
Is that your hypotenuse?
oh yeah.
Oh, it's 2.
So it'd be what?
2 red
2 red 2. Now, which one of these gives me 2 red 2 as an answer?
B.
B is the only one that's going to give me a 2 red 2 as an answer.
That was
Okay, 2 red 2. Let's see, calculator. So 2 red 2 gives me 2.8. What was the other one? 4 divided by red 2. There it is. Same answer. 4 times red 2. Nope, that's not it. And 4 is not it. So my answer has to be this one right here. You guys could use calculators on this, so I'm expecting, yes, I'm expecting you guys to do well. Now, let's take a look. If this is a square, okay, if this is a square right here, I'm going to put a thing right there. What's this side over here?
1.
1. Oh,
What's this side over here going to be?
1. Oh, wait, what? 2.
One.
1 radical 2.
1 rad 2, right? Because these two sides are the same, right?
Yeah.
If these two are the same, that makes this a 45, 45, right? So it's basically I'm bisecting an angle. Bisect means to cut it in half, right? Say yes.
Yes.
Is that box mean 90?
Yes. Yes.
What's half of 90?
40. 45. 45.
It's 45. So we get the length right there. That one should be an easy. A square has a diagonal of 5 centimeters. What is the area of the square? So, I'm going to draw another one right here, just so you can see right here. It says the diagonal is 5. So, kind of like this square right here, it's also going to be a 45, 45, 90. So this is going to be 5 is right there. What is the side over here going to be?
2.5.
What is it?
2.5 radical 2.
2.5 rad 2. Right? It's half times rad 2, right?
Yeah.
Okay, so now, to find the area of a square, how do you find the area of a square?
Length times width.
Base height, length, width, right? So it's actually going to be this times itself, right? So it's 2.5 rad 2 times 2.5 rad 2. So you can do that in the calculator. So I get you guys are calculating this. Come on now. Oh, this is my centimeters. Did you come up with 12.5?
Yeah.
Excellent. Make sense?
Yes.
All right, so we're picking up on this one tomorrow. Number 4 tomorrow, okay?
Yes, sir.
Do not lose these things, please. I cannot go and print these every time. So don't forget, like and subscribe.